we're currently facing, it is now more important than ever to have the resources to answer critical questions. This includes having access to timely, detailed, and trustworthy information to think quickly and act fast. Why? Data helps us see and understand a situation and what actions we need to take, and then understand if our actions have made an impact. Now, without further ado, let me introduce our presenter for today, a person I'm very humbled and honored to be able to engage with, TK Low, Senior Director of Equipment Operations Engineering at Kuliker and Sofa. TK manages the operations for K&S's three major business units: ball bonder, wedge bonder, and advanced packaging equipment. He leads a diverse team of innovative managers and engineers in the development of new products, focusing on design for manufacturability, enhanced product quality, and driving down product cost. His responsibilities include supplier development, establishing and sustaining operations for mass production lines, drive continuous improvements, as well as process simplification and factory automation. In the last 3 years, TK and his teams have made significant productivity gains and quality improvements for the manufacturing of high-precision semiconductor equipment with the use of advanced data analytics for improved decision-making, automation, and material cost reduction. His teams have been successful in pushing the boundary of advanced data analytics using artificial intelligence to deep machine learning for predictive analytics in operations, quality, and supply chain management. Prior to his current role, TK was the senior process manager based in Irvine, California from 2003 to 2011, developing wire bonding process technology. TK holds multiple degrees, including 3 master's degrees in applied economics, finance, and materials engineering from Singapore Management University, Nottingham University, and the National University of Singapore, respectively. Now let's hear from TK.
Thanks for your kind introduction. Today, I'm going to present a deck of slides that talks about digitization, the use of analytic tools in operation. Right? So before we begin, I want to have a brief introduction of my company, Kuliker and Sofa. Kuliker and Sofa is a semiconductor equipment solution company that build and service equipment for the semiconductor market. We are founded in Philadelphia in 1951, listed in NASDAQ under KLIC in 1971, and today we have around 2,500 employees globally. 80% of our revenue is generated in Asia, and we have our headquarters in Singapore since 2010. Our global network, we have our footprint is across the entire globe. We have 5 manufacturing sites. We have manufacturing sites in Netherlands, Israel, Singapore, Suzhou, and R&D sites scattered all around the world, including US, Israel, Switzerland, Singapore, and China, and 18 global offices scattered around the world to support our global customers. So this is K&S. Today, my agenda is a very simple agenda to talk about the use of data analytic tools for manufacturing operation. However, I want to just tell the audience, yourself, that these are the tools that we develop for manufacturing engineering and operation. It does not constrain it to only in manufacturing engineering. Any ideas that you think is relevant that it can apply to your application wherever you are, please do so. So we're going to start with a simple application that talks about health and safety, monitoring and tracing. And then we go to a more complex application in the supply performance and quality management and decision making, and with manufacturing operation analytics and decision making, right? And then we have a lesson learned to conclude. Our expectations. When we develop all these series of solutions, Health and safety was not part of it because we were not hit with the COVID-19. All this solution was developed way before COVID-19 hit us. So our consideration for developing these tools is mostly working from home, because sometimes we have staff that prefer to work from home for their flexibility. While working from home, you want to collaborate. So how do we do collaboration? And then all this we're trying to do is to do productivity improvement, right? And because of the recent COVID-19 outbreak, we insert in health and safety because some of the tools can help us resolve or solve some of the problems that are related to this area. So this is our expectation for developing the tools. Before I go into the case study, let me give you an overview introduction of our data automation and data analytics infrastructure. This sets the bedrock for what we're going to discuss later on. So on the left side of the chart, you can see the whole series of various sources of information. At the very top, we have what we call the MES. MES stands for Manufacturing Execution System. It's a system that developed in KNS where we use the tablet computer for the technician to pull work order, to pull work instruction, and to communicate directly to the machine that we are manufacturing, and then to send information to the machine to trigger certain automated process. At the end of the day, the machine, once completed the test, the tablet computer were able to pull the information from the machine, the test data, and then send it to cloud for further processing. Likewise, we have automation equipment in the factory floor. These are systems that are able to connect to the network, and they are typing and transmitting information related to the manufacturing process or the machine performance into the cloud. Like many companies, we use ERP system. The ERP system we have currently is Oracle. We use Oracle. The system is able to pull information from Oracle to the cloud. Information, for example, the work order, the serial number are all pulled from Oracle to the cloud. Finally, a vast majority of the data that we have come from supplier. So we are able to link the supplier data directly to our cloud. And all this data go into a system what we call data warehousing, where we sort, structure the data, prepare the data for further analysis. Next, towards the right side of the chart, you can see decision making. We use two aspects of the data analytics systems for decision making. One is data visualization using Tableau as the engine, and we will talk about it in details in the following slides. And the second part is data monitoring. We're able to take the data from the suppliers or in-house and then do analytics and detection. So this is data monitoring. Overall, this is the overview of how we collect data in KNS today. Let me begin with the first case study. This case study was actually a fun case study. It was not intended to develop this case study or this application, but it came as a consequences. So when we are in the beginning of the COVID virus outbreak hitting Singapore, we were supposed to do rotation of teams. We were supposed to collect temperature. We were supposed to practice BCP and social distancing. So one of the important things that we had to do at that time is to collect body temperature. So as you know, for many companies, the first thing that the company would do is secretary organizing various, printed out various forms located around the company with thermometers. And everybody at a certain fixed time will go to these forms and start collecting your temperature, measuring temperature and collect the temperature into the forms. And somebody will key into the database. One problem arises from this is that you have people congregating at a fixed spot regularly, and if somebody would have the virus will spread physically to everybody that congregated there. So this solution is not workable. The next best thing people came out is to use a spreadsheet to put in a share drive, and everybody will at a fixed time to go to the share drive and enter the temperature. But this doesn't work because at any one time, only one user can go to the share drive and open the file and start keying information. That doesn't work either. So our team, the operation team, for a lot of engineers have been exposed to digitization and have been developing solutions for digitization, came up with a solution. They say, why not I create a data collecting system using the cell phone or the mobile phone that people have and using it as a data collection. from the iOS and Android. So we cover most of the cell phone. And the first step is the system. Once you install the software, the system or the application itself will trigger you at a fixed period in the day to say, please collect a temperature. The user will then measure the temperature using a thermometer that is distributed to everybody. And then he will key the temperature and he will key the location and the health status. For example, am I on medical leave, or I'm healthy working from home, or I'm on vacation? So we key into this. Immediately, the user will see the temperature trend for the last few days. At the same time, if you look at the bottom of the application under user interface, you will see a recommended start work and off work time. This is the apps. It is the algorithm that built into the apps that allow people to have a recommended time to go home, because we believe that at the off work time or to come to work time, everybody will come at the same time, and that's not a good condition. So we want to spread out the people coming to work and off work at the different. So these apps help them to give a recommended time. Once the information is keyed and sent to the cloud, this is where the backroom do. The backroom processes is the analytic engine through Tableau will then process information and individualize according to the department. And if there is the temperature out of control, that means temperature that's above 37.5 in this case, an email will be sent to the manager in charge for further action. The next slide, or this slide, will show you a simple demonstration of how the whole backroom operation works. Let's take a look. So you can see these are the temperature collected by the department in across a few days with all the names, email there. And the manager behind the scene can actually sort and identify if there's any abnormal temperature, or if you're interested in saying for the particular person that he thinks his temperature is hovering above 37.5, and an alert will be sent to that particular manager for action, for follow action. And this is how our simple body temperature tracking works. So we use a combination of data collection using the apps and the Tableau function to do this simple application that serves pretty well. Okay, that's the body temperature tracking system. The next case study is much more related to the work that we're doing. The next case study talks about supply performance and quality management and decision making. So this set of applications was created before the COVID virus outbreak hit Singapore or the world. So let me give an overview of what is this supply performance and quality management. It's the end-to-end supplier development process. The process starts with a simple supply assessment. During the supplier assessment process, we will do SWOT analysis. SWOT stands for strengths, weaknesses, opportunity, and threats. It's like a credit history check of the supplier, whether it's capable of doing business with KNX according to our set of criteria. Then we will have development. We have qualifying and monitoring them for the first time when they send parts and sell parts to KNX. And over a period of time, we will track the performance. We will have a scorecard, a report card at every quarter at the end of the year to benchmark them whether they are doing well or they have gaps that need improvement. Throughout the whole entire year, we also monitoring the parts they send to KNX. For example, critical dimension of parts that we watch very carefully. So this is done on point 3 here. So the following slide will show you the case study of the application related to 1, 2, and 3. The first application that we have here is supply risk assessment. So the supply risk assessment app is very simple. First of all, we have a login. We allow users, regardless where you are. You can be in US, you can be in Singapore, and you can be in China. As long as you are serving a group of suppliers, that you are collecting information and you're accessing them anywhere in the world you can access, and they can perform this analysis. Right? First of all, you log in. Second, you capture the data. The data that you capture related to the risk assessment. as you enter the different criteria, the scoring, the system automatically takes your score and generates the ultimate score, the risk. So the criteria is related to our company, business, and over the period of time we develop this algorithm. So, and number two here is also the same capture, but it's in more textual based, meaning you can talk about the strength, you can talk about the weaknesses, and together with the scoring system, you give you a complete picture. Number three here is basically the outcome of the analysis. It's the report card of a supplier that you just accept. This is usually for new suppliers. You can see from the risk and the score whether they are in the certain range where you can accept that as a new supplier and do business with them further, or you can reject outright and not doing any business with them. So these systems allow our employees, regardless of where they are, they can work in office, can work from home, to collaborate and to do this analysis at the comfort of home. Okay. So let me do a demonstration of that system that we just mentioned in the previous slide. So as usual, login, password protected.
The
user can start keying information related to a particular supplier, the weakness, the strength, opportunity. And based on the criteria, the user can enter the information. Information automatically calculates the score, whether it's high risk, medium risk, or low risk, together with the swap. User review it, check everything is correct, send it, and this is the outcome of a particular supplier, about the risk, about the score, and from there, information is being collated into the server, and whoever needs to use this information for decision making can use it. This is the first example of user risk management system. The next application is supplier scorecard. Basing on the same principle of the previous acts of risk assessment, now we develop a supplier scorecard system where you score the supplier at the end of the quarter or the end of the year, so that we can identify the gaps and opportunity for supplier to improve or further or for price negotiation. Very similar to the previous system, they use login wherever they are, from home, from various regions, capture the data. So the scoring system is predefined. We have a certain criteria. And then when we perform analysis at the point number 3 here, you can see that we can lay all the supplier according to the commodity type and area, and we can lay them side by side and do comparison. And then we have an average line, an upper line, a lower line. And then we can then actually identify the supplier that are less are weaker or have much bigger gap. We can, for example, in this case, supplier towards the right side of the chart shows that this supplier have a much bigger gap. And then we can drill down to a particular supplier and perform analysis, say, in what aspect of his scorecard is lagging, and what does the performance seem, what is the performance over a period of time. We can use this analysis as a conversation with the supplier for them to improve. And if the trend is downward trend for a long time, we can actually terminate the relationship with the supplier. So this is a simple system that can use is currently being used by our company to measure the performance of supplier. So the third application I want to talk about is data monitoring. Before I talk about data monitoring, I want to give you an overview of how we collect the data from our supplier. So this chart right in front of you talks about how the data are being captured from the supplier. In this case, we have a supplier that are located maybe in China or in US or in Taiwan. Okay, so the data from the manufacturing process, in this case, there's a PCB board assembly, are being captured by supplier server, and data related to the test, to the bill of material are being transmitted at a regular interval to a server in KNS. So this is how we collect the data from on our supplier. And this is how the data looks like raw into our server. You can see for a particular critical parameter, these are data that we captured between different period of time, and we have the parameters all linked here, all prepared all are stored in the cloud. What we do with this data is very, very unique. Through the Tableau software, we're able to program algorithm. The algorithm can be a simple SPC algorithm or specific algorithm that we want to detect trends. So you can see the algorithm, this color code here, algorithm, as the algorithm applies to the data set, different colors will light up, and the count of actual how many of that algorithm is being triggered is shown here. So this is the user interface that we use to program the algorithm. With this algorithm, we are able to do detection. Imagine that a supplier is feeding you information on a constant basis, data, and then the algorithm will pick up before the material left their factory and shipped to KNS. We are able to see if there's any anomaly. When there's anomaly, we can call up the supplier and say, hey, something's wrong with your material, something wrong with the product. Please take a look at that before it's shipped to KNS. And this will prevent a lot of issues related to time, the quality, and the stressful if you're really needing this material for in real time in order to deliver to your own customer. So this helps us to prevent and save a lot of time, prevent any quality spill from coming into KNS. Okay, and so this is a detailed view of the algorithm in action. Here we have a serial number of every individual part. And the rules are here, and the different colors dot here represent different rules are being triggered. And this is part of the function available in Tableau. Okay, let me do a demo of these systems. So we can see that these are the data streaming from the server, from the supplier into our server. User can actually using the rules to trigger different color codes of the rules that are being triggered. And you can see from all these colors at the top and the bottom which rules are being triggered and for what reason. And then the next step is basically creating the alert. And when certain things have been triggered, you can basically program alert to inform the engineers or the supplier or whatever people that you want to inform through an email. So in this case, the user is setting up an email alert to a particular group of people. And then when the alert is being triggered, email like this will send to the supplier and the user for further action. So it's a very simple system that we use now to monitor our trend of the data coming from supplier before the physical goods actually arrive in KNS. I conclude with case study number 2. Now moving on to case study number 3. Case study number 3 is about manufacturing operation, analytics, and decision making. It's a mouthful word, right? So why I will feature case study number 3 is that most of you who have never been to a factory, or those of you who have been to a factory or worked for a factory, you will know that your basic thinking is that manufacturing operation is factory related. That means a lot of physical activity has to take place within the factory, and all the activities needs the physical hardware and software and the building to come together. That is true. But with this digitization that we did, so the next set of applications allow us to work from the comfort of our home and still able to run the operations from your home like you're there. So let's see how we have been done. So this is a picture of the data systems that the infrastructure that we capture from the production floor. We have talked earlier how we use iPad or tablet computer to capture those data. So I go into deeper details in this case. As you can see from the process, from left to right, we have various manufacturing process. And each manufacturing process are done by technicians armed with a tablet computer. In the tablet computer, it's programmed by our own people, our own engineers, with all the various functions. Functions of, for example, the pull-in work instruction, to pull in work order, the function including communicating with the machine that we're building and talking to the machine, sending information to the machine to initiate certain automatic testing, while at the same time, after the test has completed, information from the machine test data are being transmitted to the tablet computer and then sent to the server for further analysis, right? And also, data from our automatic systems, the robots, the automation system are also transmitting the data seamlessly to our server. And this is how we capture the data from the production floor, real time. So once all this information are captured into the database, into a cloud server, and every week our line manager will have a meeting with his team of various engineers. Could be quality engineers, could be manufacturing engineers, and also engineers supporting the line. And right in front of the manager is the dashboard. So we use dashboard created from using the Tableau software and the dashboard that links to the KPI. In this dashboard, right in front of you, there are two aspects. One is the production view, and second is the quality. So, and the dashboard is being segmented into three portions: weekly data, monthly data, and quarterly data. 4 weeks makes 1 month, 4 months make a quarter. So that allows the manager and the team to look at those data and see how far am I or how close am I towards the goal, and what can I do now in order to influence the goal towards the end of the quarter. Right in front of you is the two red bar. The first thing the manager can see is that these two red bar represent that my current data or my current performance doesn't meet with the performance as required by the target. So he needs to do some intervention, right? So he needs to understand what is within this red bar that creates this gap. So, for example, you like to know who or which processes, who is responsible for processes, what needs to be done, what parts need to be changed, something like that. So we ask a whole series of questions, probing why. So with this question start to surface out, the next step of action is drill down. So all the manager need to do is to click on the red bar, and together they enter what we call a drill down workflow together with his team and the engineers. So right in front of you is an illustration of a drill down process. In this case, the drill down process KPI is not productive hour. The reason why the machine or the technician is not performing his task due to a whole variety of problems. In this case, we can see out of process A to K, process B is having the highest number of hours non-producing, meaning something is wrong with the process, there's a lot of non-productive hours. So, and as the manager and engineer jointly drill down, you will have able to identify what is the cause. Is it a material that is faulty? Is it a systems or machines that is not performing? Or is it a workmanship problem? Which employee deal with those workmanship problems? Which parts actually fail? So in this case, he have an overall picture of various processes, and his eye and the focus will be focusing on process B, because this is where the highest amount of non-productive time are being generated together with the team. And from there, they can identify the reason and deploy the resources to deal with this process B, knowing that if I deal with process B, I can solve the problem in a great deal, rather than focusing on other more minor problems. So with this dashboard and with the mindset, with the workflow, the team can actually work from home because the data are now in the cloud, and every of the employees, the engineers, the managers working from home can access to this information and make through a conference call, through online meeting, the virtual meeting, they can jointly make a decision. And if need be, they can deploy the people in the factory to deal with this problem real time. So this is one of the ways that we can collaborate even at home with making decisions. Okay, at the end of the quarter, the systems that we have deployed is able to collate and consolidate all the issues into one dashboard. And right in front of you is the dashboard that set the goal for reducing the number of failures. So what we use is the waterfall chart as available in the Tableau software. The waterfall chart is able to plot out various problems, the top 10 problems from left to right, with the highest, the most severe problem towards the left. And within each problem, the manager can assign top 10% or top 10 failures to be resolved within a quarter, knowing that if you resolve the top 10 failures, he will meet his KPI for that particular quarter. So what he will do next is to work with the engineer and deploy the resource or assign the teams or individuals to work towards closing, solving those failures. And if everybody plays that part well and solve the problem by the end of the quarter, the whole team will meet this goal. And it's very concise, it's very clear, and the team or the individual can constantly update the status of their progress directly on the chart and give the managers overview of how is it performing as we progress towards the end of the quarter. So this is another dashboard that we can use to set goals real time, even at the comfort of home, without leaving a home, for managing a factory operation. Next, anomaly detection for manufacturing process. This is very similar to the case study number 2, when we are pulling data from our supplier, regardless where they are, can be in China, can be in Malaysia, can be US, coming into the server and do analysis and use our algorithm to flag out anomaly. So in this case, this data, as you can see from earlier slide, are coming from directly from the production floor through the NES, through the data stream coming directly from NES and all automatic system piping the data into our server. With those data, we're able to plot the data in this manner and then apply the algorithm, the rules, for example, SPC rules or rules to detect trends or a particular trending or shift in the data set. And those rules that have been picked up, those data that have been picked up by the rules will be highlighted in the color code. And from the bottom on the rules, engineers can trigger, it can trigger the engineer through the email to work on the specific issue according to what has changed. So this is one way that some of our engineers can be work from home, while some of our engineers can work in an office or in a factory, collaborating seamlessly to deliver managing the manufacturing process. So I can see that this kind of system can be applied to other applications if needed. For example, healthcare, tracing temperatures of patients or some other biometric information to detect trends. So we have come to the conclusion of this webinar, and I'm going to like to end this webinar with a few lessons learned from the journey KNS took over the last few years, way before the COVID virus outbreak hit Singapore. So what are the lessons that we learned from this journey of digitization and analytics? Let me go through them. So a few takeaways before the journey. So I want to highlight the takeaways in 3 trunks, right? The mindset, the infrastructure, and the leadership and culture. So on the organization mindset, before we embark on this journey of the transformation, a lot of data are saved in our personal computers. They are not linked, they are isolated. We use spreadsheets to analyze and visualize. Not saying that the spreadsheets are less of effective tool, but because they're isolated in a spreadsheet, it is very time consuming and very hard to do correlation. A lot of our engineers during that time are very comfortable with chart. The chart can only use in one presentation and immediately the chart is obsolete. I will never use it again. The reuse is not there. And a lot of times the decision making by our engineers and managers is basically based on their experience and lesser on the data. Sometimes they use data, but some of the data are partial data. You don't see the complete picture. When it comes to data infrastructure, as I say, a lot of the tools we use are Excel, Access, PowerPoint, really time consuming to use them, to put them together over and over again. We also use shared drive to store the data. And we briefly talk about shared drive in the first case study of the healthcare, the health monitoring, where you have shared drive, but only one person is able to use the drive. And that's very, very difficult for collaboration. Very limited data connectivity. A lot of data are not real time. People have to go to the line to collect over and over again, and this time consuming. And as I say, it takes a long time to generate a report. A typical report, in order to have a full picture, would take a week, 2 weeks to come up with certain conclusions. And in the world of manufacturing, 1 or 2 weeks wait for a report to generate to make a decision is way too long, and we may be producing a lot of defects to the market. So this is something that we have to grapple with. Finally, on the leadership and culture, before we embark on this journey, because there's a lack of data, a lot of decision making is actually from the top down and centralized. Managers, directors, or very senior engineers, based on experience, based on a lot of learning, they say, okay, this is how I see the thing, and this is how I want to make the decision. And the decision, a lot of time are guesstimation. You have a feel, and yet because of incomplete data, you are just making a partial guess. And because of that, your decision making is very limited in effectiveness. And we realize the fun part of the whole thing is that a lot of times those people, those engineers and managers that make the prettiest presentation with the most logical argument wins argument, whether the underlying facts substantiate the decision. So this is what we see before the journey. And after the journey, we are here, the three aspects change, right? For the organization mindset, we use data that are systematically captured into the server. We use business visualization software, for example, in this case, Tableau, to collect the data. And using the data, we are able to connect dashboards that are linked to the KPIs. And this is really important because when they are linked to KPIs, you are able to have an overview picture and you can then make decisions, effective decisions that relate to your KPI and your business goal. So on the mindset, this is what is changed. On the data infrastructure, we invest a lot of resources over the years to really make sure that our data are clean. The cleaning data, meaning we are structuring the data, there's no ambiguity in the data collected into a server. Again, we in the same point I repeated earlier, business visualizing software like Tableau, but not only that, we also need to train our subject matter of every processes to really learn how to use this visualization software effectively, allowing them to create dashboards that in turn link the KPI, and making sure that these data support the dashboard, which in turn support the decision making. So this is data infrastructure. Finally, coming to leadership and culture, we are driven based on KPI. So the KPI that we create and that are linked to the business objective, and the employee are constantly encouraged to identify data sets or data streams that we can capture them systematically and link them to the dashboard, which in turn link to the KPI. So every decision making is basically data driven, and because of that, we see there's a huge uptick in collaboration, in trust in the people, and in the effectiveness of the manager making decisions, regardless whether you're running a manufacturing operation or running a supply chain. So with that, I come to the conclusion of my webinar, and I hope you enjoy it, and thank you.
Okay, thank you very much, DK, for sharing what you do and some of the proactive and thoughtful approaches your teams have been working collaboratively together, and for all your support as part of the Tableau community. Before we wrap up, I'd like to share some business recovery support resources and solutions to help the audience manage through all these changes. First, we created a COVID-19 data hub, a free publicly available set of resources to help business leaders and the broader public to be informed and make data-driven decisions in the context of the coronavirus outbreak with trusted data. Many customers have said that they need now to empower people to increase data literacy so they can be more agile and make good decisions fast. The ability to develop and demonstrate data skills will be a significant advantage for companies as they find ways to adapt faster. We have created 2 offers for anyone hoping to learn or polish the in-demand data skills. The first is Tableau e-learning, and it is now free for anyone for 90 days. This web-based on-demand experience is self-paced and designed by experts in Tableau and online learning. And secondly, we are also offering Tableau Desktop Specialist Certification at a 50% discount. The discount is automatically applied when you purchase a test. Free e-learning and certification discount will not only help people reskill for in-demand jobs, these offers also will create a pool of hireable talent for organizations rebuilding their teams as we recover from this pandemic. Thank you so much, everyone. We appreciate you being here. We believe data helped you lead through this time of change. We'll make the recording available over the next few days. Thanks again for joining us today, and would love to hear from you in our Q&A section.